Welcome back. What's cracking? Here we are today to do areas of parallelograms and triangles. So last time we talked about areas of triangles and rectangles, and now we're going to talk about some parallelograms. So vocab, base of a parallelogram, altitude, height, base of a triangle, height of a triangle. We also talked about circles last time. That's what we did. Okay, so area of a rectangle is, we've gone over this, is just base times height, or length times width. So it's actually the same with a parallelogram. It's still base times height, but the tricky part here is figuring out what the height is. So your height is not, it's not this side right here, because that's a slanted side. Your height has to be a straight up and down line that makes a perpendicular with the base. So kind of like a triangle. Your height has to make a perpendicular, a right angle with the base. And that's what you're going to use. So it's just base times height, just like a rectangle. The base of a parallelogram can be any of the sides, and the corresponding altitude is a segment perpendicular to the line containing the base. Okay, so you could actually use this as, so we could use this as the base, then your altitude would be this way. Or if you use this side as the base, the slanted side, then your altitude, they've kind of extended it like that, and they have made the perpendicular line to the other side. Okay, you could also go like this to make that perpendicular line. Okay, but that would be your height there. So depending on what your base is, that will change what your height is. But either way you do it, should give you the same area. Okay, the height is the length of the altitude. Okay, so what is the area of each parallelogram? So this one, the base we want to use, we have to look at the right angle here, which is here. So we want to use the two sides that form that right angle, which is this side and this side, those two lengths. So it's just going to be 5 times 4, which gives us 20 square inches, because it's area. Now this one, our right angle is here, so we want to use this side right here and this height right here. So 2 times 3.5 gives us 7 square centimeters. Alright, simple as that. Okay, now you're finding the missing side though, so it actually doesn't ask you to find the area, it wants you to find DE, which is this height right here. So find that height, it's the nearest tenth. So to do that, we can first find the area. We don't know the area yet. And if we want to find the area, we have to do the base times height. So here's our base, here's our height. We know the base is 9.4, but we don't know the height yet. H, we'll call that. So if we look at the other side, if we use this as the base of 13, we do have this right angle right here, which forms this height. We can find the area there. So your area is going to be 13 times 9, which is 117 or something like that. 13 times 9. Yes, 117 square inches. So that's going to be the area. So if we know the area, then we can find the height by using our formula. So area, now let's look at the red lines here. So we know area equals base times height. We know our area is 117, so 117 equals our base, which is 9.4, times the height, which we don't know, and we just solve that by dividing. So 117 divided by 9.4, let's cancel, so we get H equals 12.446, nearest tenth would be just 12.4. And that is just in inches because it's not area, it's just height. Okay, so to find the missing side, you probably need to find the area first and then do some division. So I found the area using the other two bases, 13 and 9, and then divide that by 9.4 to get the other height. Okay. So that's parallelograms. Triangles are very similar. We've actually already talked about triangles, I think. But it says you can rotate a triangle around the midpoint of a side to form a parallelogram. So if you look at the triangle here and having it rotated around that point M, that actually forms a parallelogram. So that takes us to the area of a triangle formula, which is just 1/2 the base times the height. So it's basically half the area of a parallelogram. So here's your whole parallelogram. We just want this half of it. So 1/2 base times height. Base of a triangle can be any of its sides. The height is the length of the altitude containing that base. So again, the height has to be perpendicular to the base. All right. So you want to make a triangular cell like the one at the right. How many square feet of material do you need? So you know your base, so let's write the formula down. Area equals 1/2 base times height. So 1/2, our base is 3 feet and 4 inches. So that, we want square feet, so we need to actually change that to just feet. So 4 inches, so 3 feet and 4/12, because 4 inches out of 12 feet, times 12 feet and 2 inches, so 2 out of 12. Can simplify that a little bit. 1/2 times 13 1/3 times 12 1/6. Just simplify those two fractions, and then we can change those to improper fractions. That way it's easier to multiply. 1/2 times, so we do 3 times 13 is 39. 39 plus 1 is 40, so we get 40 thirds. Times 6 times 12 is 72. Yeah, plus 1, 73 sixths. When we multiply all that together, multiply all the tops together, 1 times 40 times 73 gives us 2,920 over 2 times 3 is 6. 6 times 6 is 36. And if we divide those, we get 81.1 repeating, and that's going to be in square feet. Okay, so that is how many square feet of material you'll need for a 13-foot 4-inch by 12 feet and 2-inch. Okay, and if you wanted to change, oh, we won't change that, so we'll just leave it like that. 81.1 square feet. Okay, finding the area of an irregular figure. So we've got this composite figure here. We have a square and a triangle. So the area of the square is just going to be 6 by 6. That's definitely a 6. So the area of that square is going to be 6 times 6, which is 36. And the area of this triangle, well, we know that our base right here is 6, because that's the side of the square. Height is 8. So area 1/2 base times height. So we get 1/2 times 6 is 3. 3 times 8 is 24. So that's going to be the area of the triangle. And then to get the total, we just add them together. 24 plus 36 gives us 60 square inches. Okay, and then the next it says, suppose that the base lengths of the square and the triangle were doubled to 12 inches, but the height were not, so the height remains the same. How is the area affected? So basically, your new figure, these two are changing to 12. So it's now no longer a square, it's a rectangle, but it's 12 by 6, and then, oops, this is still 8 here. Heights haven't changed. So then the area, basically, so it was 60, keep that in mind. So if we do the new area, what is happening? Okay, new area, this is going to be 6 times 12 is 72. This one is going to be 1/2 times, so your base is now 12. So 1/2 times 12 is 6, 6 times 8 is 48. 72 plus 48 is 120. So our area is going to be 120 square inches. So if you double the base lengths, that just doubles the area. If you double the base and the height, okay, you're doubling two things, so that would actually quadruple the area that you're doing. Okay. But if you only double one dimension, like if you just double the base or you just double the height, that's just doubling the whole area. And that is all I have for today. So I will catch you guys on the flip side. Have a great day. Thanks for watching. Do the quiz. See you guys later.